Hello. In this discussion, we're going to be talking about the reference angle of another given angle. So what is a reference angle? Well, we want to let theta be a non-acute angle that lies in a quadrant. The acute angle formed by the terminal side of theta and either the x-axis that's the negative x-axis or the positive x-axis is called the reference angle for theta. It's very important that that one side is going to be either the positive x-axis or the negative x-axis. You can't come off the y-axis. So you look at the terminal side, and it's the acute angle, which remember it measures between 0 to 90 degrees, or 0 to pi over 2, and that is the reference angle. So let's look at some pictures. So if you have an angle that's in the second quadrant, like theta, the reference angle is from the negative x-axis to the blue terminal side of the angle. So that angle that's on the left there is the reference angle. Although theta is more than 90 and less than 180, the reference angle is the acute angle. And that angle measures either, which if it's in radians, it's going to be pi take away theta. And theta, remember, is already more than 90 degrees, so or it's 180 degrees minus theta. So the reference angle is that acute angle from the negative x-axis to the terminal side. If it's in here in the third quadrant, then it's going to be coming from the negative x-axis to the terminal side again. So basically, the first 180 degrees or the first pi radians, you have to remove off. So it's either going to be theta take away pi or theta take away 180 degrees. That gives you the reference angle. Now this one here is a negative angle that ends up in the first quadrant. So if it's up in the first quadrant, what we're going to do is basically find a coterminal angle by adding 2 pi to that, or adding 360 degrees to that, because it's already going to be between negative 270 and negative 360. So by adding either 360 or adding 2 pi to that, it ends up being an acute angle. So the reference angle is the angle from the positive x-axis to the terminal side. And if it's in the fourth quadrant, if you got it from the positive x-axis all the way around to the terminal side, that's going to measure between 270 to 360. So what we're going to do is we're going to take 2 pi, take away the theta, and that leaves you the residual, which we'll call the reference angle, or 360 degrees minus the theta. So all these angles here are reference angles because they are acute angles. So that means they measure between 0 to 90. And you might, well, why would this be useful? Well, reference angles is going to give us an aid of finding trig functions that are not necessarily between 0 and 90. So for example, if I want to find the sine of 120 degrees, that's not one that I have memorized. So you're going to find a little later that taking the sine of 120 degrees would be like taking the sine of its reference angle. Well, the reference angle to a 120 degree angle is a 60 degree angle. So if you have a 60 degree angle, taking the sine of 120 is the same thing as taking the sine of 60 with one extra bump in there. It basically means, where is 120? Well, 120 degrees is in the second quadrant. So sine is positive in the second quadrant. So therefore, taking the sine of 120 degrees must be positive. So, but sine of 120 is taking the sine of 60, which we know to be root 3 over 2, because that's one of our special angles. So therefore, the sine of 120 degree angle is root 3 over 2 positive. But on the other hand, if you're taking the cosine of 120 degrees, that would be like taking the cosine of 60 degrees as well. But in that case, it's 1/2. But since 120 degrees is in the second quadrant, cosine is negative in the second quadrant. Putting those two together, okay, cosine of 120 is the same as taking the cosine of 60. That makes it 1/2, but it's negative because cosine is negative at 120 degrees angle, which is in the second quadrant. So the cosine of 120 degrees is negative 1/2. So that's kind of how it works. You kind of use the reference angle and the angle that where the quadrant where it ends up. Remember, all students take calculus in a previous video. So you're using those two together. So you're using the reference angle concept and where there's positive or negative in that given quadrant, putting those together to evaluate other trig functions. And we'll do a few examples of those later. So now let's first find the reference angle of these angles. Okay, now all we're doing here is this is just the reference angle. That's all. So we look at 210 degrees. The reference angle, I call theta sub r, that's my favorite one to use. Well, 210 degrees, we know it's more than 180. So we're going to take off the 180, and that's going to be 30 degrees. So taking a 210 degree angle, that's the same as a 30 degree reference angle. Now, I'm not saying 30 degrees and 210 degrees are the same value. But what I'm saying is if you find the reference angle between the negative x-axis to that terminal side, it would end up being 30 degrees. And notice, 30 degrees is acute. Okay? Now, this one is just kind of an observation. Negative 60 degree angle is in the fourth quadrant. It's going from the x-axis to a terminal side that ends up in the fourth quadrant. So a negative 6 degree angle is acute if you just take off the negative. Now 4 pi over 3, well, 4 pi over 3 is again in the third quadrant. So that's going to take off pi. So that would be pi over 3, also known as 6 degrees. Now again, I'm not saying 4 pi over 3 and pi over 3 have the same measure. I'm saying the reference angle for 4 pi over 3 is pi over 3, because pi over 3 is acute. Now again, in itself, you'd probably be like, well, why is this so important? It comes in a bit that, that what we do is if we want to take the sine of 4 pi over 3, that we haven't even approached something like that yet. So if you want to take the sine of 4 pi over 3, what you have to do is take the sine of pi over 3, because that's his reference angle. So taking the sine of 4 pi over 3 is taking the sine of pi over 3. But 4 pi over 3 ends up in the third quadrant, which sine we know is negative there. So sine of 4 pi over 3 is a negative square root of 3 over 2, because the sine of pi over 3 is the square root of 3 over 2. So the sine of 4 pi over 3, if you put it all together, is a negative root 3 over 2. Okay? And the next one, we got negative 7 pi over 4, and that ends up back up in the first quadrant. So if you just add 2 pi to bring it down a little bit, that is pi over 4. So negative 7 pi over 4 and pi over 4, that is its reference angle. So again, I mean, if you want to take the tangent of negative 7 pi over 4, that could be very overwhelming. Tangent of negative 7 pi over 4. But just reduce it down to its reference angle, it becomes a whole lot easier. So this concludes this discussion. If you have any questions on it, you let me know. And you have a good day.